Hi, in the second part of my video about the CNC and electronic PCB, I will show you how to generate all the need file from the electronic CAD to the CNC machine. First, I use Altium Protel as a CAD design software. And the file we need to generate to go further is named Gerber. Gerber file is a standard format to exchange data between the PCB software. So generating the file Gerber for any CAD program, that will not be a big problem. So here, file, fabrication output, Gerber file. Okay, inch is the default. Is my my unit in on my design. 2.3 is the format, the decimal format. After that, on layer, you select the layer you want to work with. In my case, bottom layer and top overlay. Never mirror the layer. We will do this job further. With drawing, nothing to do. Aperture, nothing to do. Advanced. Be sure that the X and Y is larger than your PCB. Here, separate file for each layer. Yes, that's what we need. Suppress, leading, reference to origin, on sort, and optimize. Now just have to click. We see in the Gerber viewer in Altium the generated file, but automatically the file had been saved in your project directory, so we don't care about this file, so just close it. Now we need to generate another file. It's the drill file. For the drill file, once again, file, fabrication output, and say drill file. That's the same thing as for the Gerber file. Okay. For this option, you click OK too. You see in the viewer the location of the hole, and that's the same thing. The file had been saved in your directory, so we can close this file. Okay, so the work to do in your CAD software is now finished. We will go in CopperCam. CopperCam is a software that load Gerber file, and you set up all the things you want your CNC do, the drill size, the milling drill size. There's a lot of options. It's a bit long to explain everything, but we will do the minimum. Okay, now we need to open our first layer. So file, open, new board, and I will load first the GBL is a Gerber bottom layer. Okay, it's asked me if it's okay that the external line in red is the contour of my board. Yes. I will open now. Additional layer. Okay, Gerber top overlay. That's my top overlay. And the drill file, I open drill file. and it's weird a bit because the good file to load for the drill file is the txt file. I don't know why. And the DRL file don't have the right format. It doesn't work. So don't forget, for the drill file, it's the txt file. Okay, is it valid? Yes. Like you see, you have on the screen, you have the bottom layer, you have the silk screen in back, you have the drill. So, like I said in the first video, very important at this point, you must set your origin to your left bottom cross. That's done. Okay. Now, because we will work on the PCB on both sides, we must invert some layer. For that, I forgot to say, here you have the icon, three icon. The first is the first layer add load, so it's my GBL. The second one is the top overlay, and the last one is the drill file. So if I take the second one, I have in the first place my screen, and if I click on this last, we have the whole. So we have some operation to do different on each layer. Like the first one is my bottom layer. The bottom layer is invert compared to the silk screen. So we need to invert this layer. Now we are on the layer, just have to go here and click invert. It's done. And like you can see, the whole has follow our decision. At this point, we must check for the tool we will use to mill the PCB, drill the PCB. I don't know if you didn't watch my first video. My milling machine is equipped with a laser, 2.5 watt laser, and I paint my copper clad board with black paint, and the laser make the contour of each pad and track, and burn the paint. So after the job is done, I take the board and plunge into acid, and after some time, all the space between the black paint, the copper will be removed. It's easier and it's faster than milling mechanically like almost other people do. To do a PCB with the milling standard size, maybe 6x6, it could take with the milling could take 4 hours, something like that. But with the laser, it took about 20 minutes, and the result is better than the milling, and you will never break a bit. Okay, now we are back. So yes, that's a tool. I forgot. Parameter. Okay, tool library. Okay, here we saw that my tool number 1 is my laser. The specification, the diameter is a cone, angle is 1, and the minimum distance here. Okay, that's fine for me now. Okay, parameter, select tool. There's many options, but you must take that one by one. Now we will engage. So this part here is about the engaging tool. So didn't need to check read that. So that no. The same thing for no. So I go back in this section. So okay, we'll see again. It will be my laser. The deep is not important because the z-axis will not move. So we can enter almost anything, and the speed of the laser. In the other side, you must check for the drilling option. I work with a small homemade PCB, so I almost always use one drill bit. So here I take the option use the same tool for each hole, and the deep drilling is the 2.2 inch speed. And okay, click OK. Now the tool have been select. It's now time to generate the tool path for our PCB. The way we have to do is go here and click on this icon. Same thing again. Okay, here the laser is a very small dot, so the spacing between the track will be small. If you need to have a larger space, you can use more successive pass, so your spacing will be larger. But in this board, I don't have this problem. Okay, I click OK. In computing. Okay, now you have the result of where the laser will pass to leave the appropriate copper. At this point, we have to go there just in the file, save. Once again, you can check your options, but it's fine. Okay. At our bottom, replace, yes. Okay, now that's fine. The height of the tool, okay, okay. Here we will set that we want just to engage, not contour, just that. Click OK. The file is now generated. The file generate said that it's now a G-code file. G-code file are the standard format for CNC. For the drilling, okay, so that's fine too. File, like I said, the option here. Okay, drill, yes, it's fine for that. Drill only and not contour. Click OK. It's done. Now there's some tricks here to do. We go to the silk screen layer. Okay, the screen layer is done like if it was a track, and that's not what we want. We want just a single line, thin line of thickness for all this stuff. So the way to do is a little bit special. Go on the track, right click, and take the option engage in the center of the track. Detect that there's all those tracks with the same thing. You said yes. You said that all the lines now are like if it was draw with a pencil. We must do the same thing for the text value. Engage in center. Yes for all. Have two different lines, same thing. Gave, yes. That's an error. I make your it's not the same size. So it's fine for that too. Okay, now I only left the cross. Yes, and the center pad. Okay, now we have to generate the toolpath. Same thing as before. So you see now where the this little screen will be. Don't care about the whole alignment. It's normal. That's not correct because that's one on the bottom side and the other one is on the top side, sub side. Okay, now save. Blah 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 blah. Okay. So, whoops. And save. Okay, that's fine too. No, it's now the engage only. Not the twitch. Okay. No. Just 1 second. I think I made a mistake. Okay. Okay, on my file there, bottom layer, drill, and screen. Okay. So that's it for copper cam. At this time, we have to work with the laser file, and some modification need to be done because the Normally the spindle, the Z axis is going up and down for switch to a track to another track or an hole to another hole. But the laser, it's not the way it works. The laser is constantly at the same height, and you have to control the on-off of the laser. So in the G-code file, all the information about the Z-axis must be converted to be the control for the laser. I use for the control for the laser with the spindle on off, so the M3 and M5 command in the G code. So to make more simple, I had written a little software where it is here. There's many things inside the software. I will just talk about some simple thing. Many times when we change of material or height or anything, we never know what we need as feed rate, laser power, and all those things. So in my little application, I just have to set the feed rate I want, the laser power I want, and make a test via the button here, draw line, draw on y-axis, draw a circle. So you can do that at the feed rate you want and the laser power you want. So once you find the right setting, you can do the job, the appropriate job with those values. You will save a lot of time. Okay, on this side here, that's the I call the G-code uploader, but it doesn't make only uploading. It takes your G-code file from the CopperCam and transform this file to work with the laser. So I just have here to select should be the last one. So it's our bottom layer, and now we have two choices: send directly the convert G-code to the CNC, or send it to a file. So for now we'll send to a file. You have all the modifications that have been done in the file, and the file is in the same directory as the original file, but is named now there's another with the same name plus laser underscore. So this file, the bot laser, could be sent to your CNC for the laser operation. You have now a choice if you want to send the file to the machine via my application, or if you want to send it via another application. One of the best applications to control the CNC is not really an application, is the website Chili Pepper. That's a wonderful part of work. You just have to make a quick tour and you will see that it's a easy to work application. You just have to take your file, example bot laser, drag over the center, and poof, the file is there. So just have to press on play if everything is well set up on your CNC. and the job will begin. Once again. Oh yes, that's what I want to talk about. When you make the conversion in my software, you can set the feed rate, laser power of your choice, and the code of your of your circuit will be executed with those values. So if you find your laser is not enough powerful, you just have to lower the feed rate, and the paint will burn without any problem. Is there more things to talk about? Just 1 second, I will think about that.